everyone being here this morning. So this is the third of our series of 6 sessions we're doing here over the first 6 months of the year on getting into some deeper details around the Vermont RBES, specific to the updates for this update, which will be coming into effect in July, and then just getting into just more details about different components of the code. So what we're going to get into today is the details around the 3 different compliance options for the code. So it's not about just technically following what the code details for specifications and process, but also how to document that you've done so. So that's the subject for today's content. The content that we are sharing is copyrighted by ICC. So just putting this disclaimer there at the beginning to let you know that this is copyrighted content from ICC and can be found on their website. Also the disclaimer that we are here to support the code, not to enforce the code. So just here to share information and provide context for how the Vermont RBES works. If you have questions in general about the code, you can reach us as the Energy Code Assistance Center at that number that's listed here. And then also the Vermont Public Service Department is the state entity that oversees the code. And if we have questions for interpretation that we can't quite nail down, or if you have some deeper questions in the code, you can contact the Public Service Department as well. So just a level set about where to find this content and to get into all of the different, this code, which we're still operating under, which is the 2020 RBES, and then the updated code content that is available right now until the code goes into effect in July. It can be found on the Department of Public Service website. So this is the website and links to go to and to navigate towards under the efficiency tab on the left-hand side of the landing page. And then if you click into that residential standards, what you'll see right now, this is a screenshot from the website today, or what it would look like today. So you can find information about what is available for the updated Vermont 2024 RBES. It is not published yet with the ICC. The handbook is not prepared at this point yet. So what is available are in these 2 links right here, which are the red line, which is basically the edited version of the 2020 RBES with all the changes for 2023 in it, or 2024. And then the other one is a more cleaned up version of that, but still includes a lot of edits. So these are the places to find the 2024 RBES content. And once that is all published and updated along with to the level that everything will need to be for access as it is right now for the 2020 code, this is what you'll see, and this is where you can click into the specifics of content relating to the code itself, the actual ICC published content, the handbook, the certificates, both the RBES certificate if you're the builder or the party certifying the home, verifying the home as being compliant, and or the owner builder disclosure statement and some other supporting content. This is also where the link to the ResCheck tool is to link into to do one of the compliance options that we're going to detail today. So what we're digging into is the fact that, the code lays out the performance requirements and the process for building a home that is building or modifying a home that would be fully compliant with the intent of the RBES statute. So all of the details around design, installation, performance, etc. But then all of that needs to be documented and needs to be reported out as for showing compliance. And so this is the part of the code that we're digging into today, the certificate of compliance, the RBES certificate. This is required to be completed, showing which compliance option was chosen to meet the code, and completed by the builder, general contractor, engineer, architect, whomever it is that was responsible for the specifications and construction of the home. The copy of this is to be completed and submitted to the homeowner, to the town that the house was built in, and then a copy also submitted to the Department of Public Service to be filed, and a copy of this to be available in the home, to be kept with the home as well. So this is what the code certificate looks like. We get a lot of questions of what is this and how does this work? How do we fill this out? So we're going to get into that in detail here today. The top half of the code certificate, and this is the 2020 code certificate. It'll probably look a little bit different for 2024 RBES, but we do not have that available yet to look at to share with you here yet. But the same general framework has existed from the beginning. So the top half of the code certificate is just the basic information about the house, what type of project it was, whether it was a new home or if it was a retrofit or an addition. And then below that general project information, you see three different categories here. We have package plus points. This is showing which compliance method you've chosen to use. So package plus points and the required inputs for that compliance option. Option 2, ResCheck software, where you're going to enter in the results of using that software. And then option 3, HERS rating, ERI, energy rating index, which would be working with a third party to do the verification. So that is the top half of the code certificate, where you're going to be defining which compliance option you chose to use. And then the lower half of the code certificate is more specific detail and data about what was installed in the home, both the thermal envelope, air leakage, ventilation system type and flows, any solid fuel combustion equipment in the home, mechanical systems, your basis of design for heating and cooling equipment in the home, any ductwork, etc. So we'll go into this a little bit more detail at the end, but that's how the code certificate breaks down. And let's get into talking about compliance. So the content we're going to be focusing on is in chapter 4 of the code, the ICC document. Most of what we know and reference for code compliance lives in this chapter. So we're going to walk through where you can find the compliance options in that chapter and go into detail about the differences between each of them. So the most common one that most of the industry in the state, I think, is aware of is the packages approach, because if you're looking for actual like numbers and R values and U values for reference in the code, this is where you're going to find it, is in the content that relates to the packages plus points option. So this is what would be considered prescriptive compliance. You're picking a prescribed package of performance for a building envelope, essentially, and systems, and complying with that package completely, and then earning points. So we'll talk about that. The second option is a software, the ResCheck modeling tool. And this option is intended for the builder or general contractor, architect, the person doing the code verification work for the project, is entering inputs about the building and using that tool for verification purposes. That's a user open approach to take for code compliance. And then the third option is using and hiring and working with a third party HERS rater, home energy rater. And this is a more granular energy modeling approach that takes in a lot of factors into account that it can be used to show code compliance as well. The difference between the ResCheck and the HERS options, both are energy modeling to show compliance. The ResCheck option is simply looking at the performance of the building envelope and using the comparative analysis of that for whether or not the building will comply. The HERS option takes into account the efficiency of mechanical equipment, any solar or renewables in play. Those components of the overall building will have an impact on the rating score and the flexibility to show compliance. So digging into packages plus points, again, the prescriptive approach. Why would you go down this road? This is, like I said, one of the more common approaches that is seen to show code compliance. kind of lands this way by default often, because builders may not be aware of what the other two options entail and which way to go after it. But it's pretty straightforward. Like I said, it's prescriptive. So you're choosing a package of performance and then meeting the criteria of that package in your specifications for the building. So you're not modeling anything. You don't have to navigate through a tool. You don't have to hire someone to do this for you. You're just kind of going into the details and following those. And what's deeper to it, though, is that it's not just picking a package and then that's all you need to know. You need to be following the other requirements that live in Chapter 4 and some of the criteria in Chapter 3 that leads to design around mechanical ventilation and combustion equipment and or heating and cooling equipment. So there's overlap with other trades that need to be accounted for if you're using any of these approaches, really. But if you're going to use the prescriptive approach, you need to go deeper into Chapter 4 and look at the full context of what's required, not just look at what package option there is and follow that package. So what this requires, and we're going to be talking about the details here that are shifting for the 2024 RBES. The content you see here in green are changes that are going to be, you'll be seeing from the 2020 code to the 2024. So there's no longer, if you look in the code right now, you will see two tables referenced for prescriptive compliance, one for base code compliance and then one for stretch code. As of July 1st, those tables are combined as a single table in the code, which I'll share with you here in a moment. So that's a difference that you'll see from the 2020 to the 2024 RBES. So the way this works is you're going to be choosing one of those two packages, and basically it's a single package because the other package option, number 2, is for log homes only. And then you pick what you want to use for the package, and then based on the square footage of the building, the finished square footage of conditioned area of the building, you need to then earn points that are very flexible. There's a lot of points options that go beyond what the base requirements dictate, and those are found in these tables that are referenced here in this slide as well. So all this is in Chapter 4 of the ICC document. So we're going from what's in the 2020 code right now of 5 package options to choose from to this is the new table for package options in the code. And as I said, package 2 is specific to log homes. So there's a specific criteria available to reference from the ICC about log home options. So we're looking at essentially what's in this table right here for options for ceiling types, flat, slope, wall, above grade walls, basements, foundations, slabs, windows, etc. So these are the prescriptive R values and U values that are aligned with prescriptive compliance for the code. You'll see that another difference between this table and what's in the 2020 RBES is that you see a U value referenced here rather than just the R value. I'm not going to go into deep detail on that now today, but that has been now being transitioned into as the ultimate requirement for compliance for the different components of the building. So the U factor isn't the inverse of the R value. So you can go back and forth between the two. And a U factor is typically used when you're doing an assembly value, when you're weighting the value of all of the components in an assembly to give you a performance factor. So we don't have the time to get into how that would all calculate during this session. There will be a session at the Better Buildings Conference in a couple of weeks here that's going to be run by Richard Fazy from Energy Futures Group and Jacob Debarakuzen from New Frameworks. And I think they are going to try to go into this topic a little bit more about that U value, R factor, or R value comparison. So this is the updated points table that's in the 2024 RBES as well. So again, this combines what is currently in the 2020 RBES of 2 different tables. You look in the code right now, you'll see one table of points requirements for base and one for stretch. They're combined here for the 2024 RBs. And I know I'm going back and forth on the language here of 2023 RBs and 2024. It's showing as both right now. I believe that this is going to be considered the 2023 RBs when everything gets published, but it's also, if you look at the department site right now, it says the 2024 RBs. So I don't mean for there to be any confusion on that. We're talking about the updated code here for July, bottom line. So if you're looking at this comparatively to what's in the code right now, you'll see that these stretch code points have increased a bit over what there are right now. The base code points are about the same or are the same from the 2020 RBs. What is changing is that there is a much more expanded list of points options in the 2024 RBs. So there's going to be a lot more nuanced ways to earn the points that are necessary based on the square footage of the home. It's expanding beyond the building envelope enhancements, looking at things like embodied carbon and insulation material choices. So that's a way to earn points. It's heavily weighted towards whole house electrification. So if you're going to be using heat pumps as the primary heat source, whether that's ductless, ducted, air to water, geothermal, whatever combination thereof, that there's big points available for shifting load from fossil fuel equipment to heat pump equipment, water conservation as well. So these are just screenshots of the full list of points options. It's not expecting you to read this from where it is right now, and it's also a little bit challenging to read in full context here with all the strike throughs, but the intent here is that this is an expanded list of points. If you do want to look at it in more detail, if you're in the midst of trying to specify for a build that will be starting after July 1st of this year, you can, again, this is the link to where you can find the updated document. But going back to the beginning of the slide content, we have the ICC or the Vermont Department of Service link to get you there as well. And we'll drop that in the chat here before the meeting's done, so you can link there directly. So as I noted at the beginning of this, those are the prescriptive requirements for the different building envelope components. You know, that is what is defined in the table and your package option. But beyond that, and as you start to go into the points options go expand beyond the building envelope components and get into mechanical equipment, air leakage, water use, et cetera, you know, heating and cooling equipment. So the scope goes beyond the building envelope as far as ways to be increasing the efficiency of the home and earning points. And also in chapter 4, beyond the the beginning sections in chapter 4 that have the table and the points options, are a full section that goes into more detail about actual installation requirements and process and guidelines around putting the components of the building together. So this is what I was referencing earlier in this section about needing to go deeper into that chapter to really follow the full intention of what the code is requiring. These sections of chapter 4 are also apply to and are relevant to the other two compliance options. If you're choosing to not go prescriptive and use res check or hire HERS rater, everything in R4022 that covers these different components and requirements around installation and process and mechanicals, et cetera, are all relevant to any of the compliance options chosen. So this isn't just for prescriptive compliance. What's in this section of the code applies to any compliance type that you're going to choose to use. So these are some of the topics that are covered in that section of the code. There is another table that goes into more detail around detailing air barriers and the alignment of air barriers with insulation in the building shell. So this gets into more granular detail about that alignment and connectivity and approved quote unquote options for detailing those assemblies and creating that continuity. So a lot of this, if you've been doing this stuff for a while, has kind of become common knowledge. We've done a lot of work to change process in the industry to align with high quality and well detailed air barriers and insulation details, but this section and this table in chapter 4 goes into more detail about the specifics to get there. So I'll take a quick pause here to see if there's any questions on prescriptive compliance.
I don't see any in the chat just yet.
Okay. All right, we'll jump into res check, but feel free to, pop a question into the chat or raise your hand or whatever as we go along. Happy to answer any questions. So,
wait 1 second.
Yep.
Go ahead, Bill. You should be able to ask your question.
Hey, Steve.
Hey, Bill.
That looks so straightforward. Why would anyone choose to go another route? I mean, I can't see it.
Well, it can be a lot of detail to navigate, but it is meant to be pretty straightforward, and it's kind of, as I said, meant to be the default approach, and it often is the default approach for showing code compliance. Res check, I think, it was used, I think, more early on in the early 2000s when the code was first coming into play. I don't really come across it talking to a lot of builders or many people. I think some architects use the res check tool to kind of guide some of the design decisions during design process. But prescriptive is kind of the commonality being used for showing code compliance. The HERS rating approach was what Efficiency Vermont's new construction program offered for years, up until the past couple of years when we had to sunset that program. But that's definitely another highly valuable option to choose, is to work with a third party. We'll talk about that in more detail in just a moment too.
Well, my point is to get ahead of the process so you have a clear checklist of what you're going to buy and how you're going to put it in and
Yep.
who's going to do it, and have that plan, because too many times, and you saw it yourself about that slab edge where we just were, they don't even think about it till it's already done.
Yep.
Then
Well,
it's too late.
That's how the code is written, and any of the ICC codes, the International Residential Code, the International Building Code, the Energy Code, it's a design document. And if you read through the code chapter by chapter, it iterates to the design and process of putting a building together. So that's how I try to communicate when I train on this, is to look at the code that way. Don't just dip into different sections to find specific information you're looking for, but try to take it into context and communicate out with the different trades involved in a project to make sure that none of those pieces of that process are missed along the way.
Thank you so much.
Great. Thank you, Bill.
And Steve, we have a question. Does square footage includes crawl spaces inside of thermal envelope? Is that correct?
Well, anything that's considered to be conditioned or semi-conditioned space. So if it's crawl space that's connected to, a basement that has mechanical equipment in it and heating equipment in there, then that would be considered yes. If it's isolated from the conditioned space of the building, that would be considered outside of that envelope area. So it kind of lands with where you're defining the building envelope.
Great, thank you. And that's it for the moment.
All right, thank you. So ResCheck, again, this is an energy modeling tool, open source energy modeling tool from the Department of Energy. So these are the links to go to get to that option and use that tool. So this is the alternative to using the prescriptive packages. What this is using or doing is taking the U factors of different components of the building and then doing a weighted area calculation that takes into account the sum of the different components of those assemblies to show compliance. So this is a more is a typical sort of modality for modeling energy performance or thermal performance of building assemblies. And this is what this tool does for you as you enter in the different components and the different factors. These are the minimum U factors that are in the code for use when you're using this approach. So I'm not going to get into the details about the UA alternative option to prescriptive compliance versus ResCheck. It's using the same approach. If for some reason you can't comply or don't want to comply with what the prescriptive package table offers, this is an alternative that gives you some flexibility in looking at using, different window or glazing options that are not landing under the prescribed U values in the table, or different wall assembly types or tricky things that are out of the ordinary that you need to account for based on the design. This is one of the approach. This or using a HERS rater would be the approach to take to get around those design considerations. These are just a couple call outs that are in the ResCheck section, but this is, this applies to any building type at this point as well too. So just an update from the 2020 RBES to the 2024 is that the building air leakage requirement has dropped from 3 ACH to 2 ACH. We're also calculating it now as CFM per square foot of surface area. I'm not going to talk about that in detail right now too, but it's just a different way of taking the blower door number and data and putting it into a comparative definition in the end. And balanced heat recovery ventilation equipment is now required in the code. And that applies to, again, any of these prescriptive ResCheck or HERS options for showing compliance. So the information on the balanced ventilation requirements exist in Chapter 3 of the code. So if you want to look into what is required for ventilation, that can be found in Chapter 3, Section R304. But these are some screenshots to show, actually, this is a screenshot to show how to get the performance data for the balanced ventilation equipment that's called out in the code. This is through HVI, Home Ventilation Institute. This is a kind of an industry compendium of all the different ventilation equipment on the market. Manufacturers list and publish the testing data from the equipment that they have through HVI. And if you go into HVI looking for a ERV or an HRV that you're considering to use, you can click into the data that's published through HVI, and it'll give you all the performance specs that would show you whether or not the model that you're looking at will align with what the code requires. So we don't have the time to go into this in more detail right now, but something to start to look at and play with if you haven't looked at before. What this is giving you right here is the outdoor temperature that the equipment's been tested in, what the actual airflow is, what the equipment running, and what the sensible recovery efficiency is. So this is the efficiency of the heat recovery of the equipment. So these are the kind of the primary data points that the code is looking at and defining. What is also nice about this listing too is that they do have some cold climate testing, performance testing data. This is a Panasonic unit, and the Panasonic units have been tested down to -13 outdoor air temperature. So this is good data to look at to make sure that you have a piece of equipment that's running when it's cold outside. So this is another tool to be used if you're not aware of it to dig into more performance data on ventilation equipment. So where can you find the ResCheck software? This is going back to the Department of Public Service website. Again, in this section that covers all of the code information that I had a screenshot of earlier in more detail. So you can click into the link here. That will take you to the Department of Energy website. And this is then the actual link to the tool itself here. So there's a guide you'd want to read and look through if you haven't used this before. But once you click into the tool, you'll create an account, and then this is what the landing page of this tool looks like. So you're clicking in to create a new project. And then once you create and name a new project, you have access to it to change and modify, delete, etc., and move through the process. And what the process requires is, as you define what the project type is going to be, you pick which code you're looking to be complying with. So there'll be a drop down, and this is not updated yet. We don't know when the ResCheck tool will be updated with the inputs and the data for the 2024 RBES. But when it is, there'll be a drop down for the 2024 RBES. If you go in there now, you'll have the 2020 RBES to check. So pick your code, pick the location of where you're building, because that has an impact on some of the performance modeling data that goes into the tool, construction type, and then if you're using ResCheck as your compliance option, you're going to click here on the performance alternative. And then just more building characteristics. This is where you need to know accurately the square footage of the building. You need to know the building orientation, because as you model out the different components of the building, you're going to be defining which orientation the walls are on and the different components are on. So this is the basic inputs about the building that gives you then the basis for the modeling that you're going to be doing. This is what it will look like when you get that information together. And then as you go through, you start to pick out your different components. So checking into the envelope tab, you're going to have options for top of the building, middle of the building, and then the base of the building. And depending on what you're building, you may have multiple inputs for each of these. You may have an input for a full height 8-foot basement below grade, and then have a crawl space adjacent to that. You're going to have to model each of those foundation types independently, not individually. If you have different assembly types for different walls or different windows and different walls, you're going to need to be modeling those out individually as well. Same thing with the top of the building. If you have flat ceilings, slope ceilings, knee walls, etc., you're modeling out each of those components individually too. But at a minimum, for walls, you're going to have 4 walls. Oops. You would have 4 walls, if they're all the same specs and same components. This is where you can put inputs around cavity insulation and continuous insulation if you have both, and square footage of each of those sections or each of those wall surfaces. Attic, similarly, if you have a raised heel truss or a standard truss, you'll be putting both a cavity and a continuous insulation value in there. If you have a 2x6 bottom cord to that truss, that would be considered cavity. And then if you have 12 inches of open cellulose on top of that, that would be considered continuous insulation. So this is where you break down the building assemblies in more detail. And this is what is then used for the weighted U value approach to show compliance. And this is what you see as the output here of what the actual U factor is for those different assembly types. And then if you're doing a wall, you have to account for what the actual cavity or general wall area is and what the components are in that. Again, either cavity R value only or cavity plus continuous. Then you need to be modeling in how many doors, if there are doors in that wall, north, west, south, east, west, and what the square footage of that is, the U factor of those doors, same with windows. So, you're piecing together the entire assembly for each of the components of the building. When you go into the detailed inputs, this is what it's gonna look like for actually entering in the different components. So you're dictating what type of assembly the framing is, which orientation the building is compared to the orientation that you put at the beginning of which way the front of the building faces, north, south, east, or west, cavity value, continuous value, etc. So these are just some examples of what those detailed inputs look like. There are some helpful construction details shown in the tool itself as well too, that help define some of the definitions for how to break out different assembly types. So this gives some more detail about how to be defining like what is below grade and what's above grade and depth of insulation, et cetera, when you're naming a foundation insulation input. So this takes a little playing around with to get used to it and to model through the different components. But in the end, what you're looking at is, you've entered in all the building assembly types. You've then got to go through another checklist that kind of covers that section I was referencing earlier in chapter 4 that goes beyond the specified component requirements and goes into the more of the details about how the building is put together and how those different components are put together. So there's a whole other checklist and some other inputs you got to enter into there.
And Steve, when you get a chance, we do have
Yep.
a couple questions coming in.
All right, sure. Let me just cover the last one here and then we'll get into that. And then finally, this is the certificate that will be, that is the end result of all of your inputs, which shows the different building assembly types, the different component values, square footages, et cetera, what the proposed UA is for those assemblies as you've modeled them, and then what the code requirement is and how it compares. This example that this screenshot is taken from here is showing that what has been modeled here under this proposed component values is not aligning with the minimum performance requirement. So it's 8.2% worse than what the code requires. So what that means is that you'd have to go back into your inputs and consider your design and start to balance out and weigh out some comparative changes to component values here to get you to come in under the maximum U factor, U value requirement in the code. So this is what you would be iterating towards as a final output of using the ResCheck tool. And then this would be accompanying your RBES certificate as the documentation to support your ResCheck compliance. And then I'll take a second to look at what we got for questions here.
Yeah, just a second. We have a hand raised, so you should be able to talk.
Hi, Alex. You can click on your mic there to speak if you can.
Yep.
Sorry, I didn't realize I pressed raise hand.
No worries.
Okay. All right, no problem. So for questions,
looking through them here now.
I see how ResCheck uses the R value / U value of components times the component square footage. Is there any accounting for or constraint on the square footage of a component under the package prescriptive method? For instance, is there an accounting for or constraint on the amount of fenestration?
Got it. No. In previous iterations of the Vermont RBES and the early versions of it, there was a maximum glazing percentage that was called out. That hasn't been a factor since 2015, I believe. So, glazing percentage does have an impact when using ResCheck. If you have a low U value for the window spec, or let's call it a high U value, a lesser performing window specification going into in a large area of glazing going into a higher performing wall assembly, that will have an impact on the overall assembly. So you could have a good high R value continuous wall, assembly, but if you're putting a high U value lesser performing window and a lot of percentage of glazing into that assembly, is going to have a negative impact on your overall compliance. So it does have a factor there, but there's not a maximum glazing requirement anymore in the code.
Great.
And
thanks.
then Bruce, you have a question of what temperature does one use from the HVI table for the sensible recovery efficiency? 32 degree would be, I guess it doesn't say specifically in RBES, what to use, but I think it's for our climate zone, 32 would be considered the rating basis. It is worth, again, as I noted, looking at what performance data is available for the -13 criteria. -13 testing data comes from the Canadian requirements for HRVs and ERVs. Canadian requirements call for testing data at those below zero temperatures. But if you're looking at the reference in those tables, look at the 32-degree performance data.
Great.
And
Next question, ResCheck is sometimes useful as a compliance method to allow trade-offs between selections. Why is ResCheck not allowed for use with stretch code?
you know, it's a good question, and there's not a specific answer to that in the code. But you know, stretch code needing to be going beyond the base performance of the building, you know, prescriptive compliance, it's a higher points total necessary for stretch code versus base code. And as I was talking about earlier, the table, as you look at those points options, really iterate towards mechanical system enhancements and going beyond just the building shell to show compliance and earn enough points to meet stretch code prescriptively. A HERS rating, and using the ERI approach, accounts for the efficiency of the mechanical equipment, and the more efficient the mechanical equipment and any use of renewables, et cetera, has a big impact on the HERS score and your compliance. So the odd duck out here is ResCheck, which ResCheck, as I've noted, is only taking into account the building envelope performance, the shell performance. So I think that really is the factor of why ResCheck is defined as not being an option for stretch code.
And
next question.
Can ResCheck also be used to meet the stretch code associated with point system? So kind of wraps up your last question.
Yeah, no, those are two different things. It's an either or here. You have, for stretch code, you either have to use the prescriptive table, prescriptive approach, or work with a HERS rater. You can't combine using ResCheck and prescriptive. All right, I'm going to jump into, I see there's a follow-up, Kate, there, but I'm going to, if you don't mind, just jump into the HERS rating info here as well. I want to get through that before we're done, and then I'm happy to stick on to answer any more detailed follow-up questions too.
Yeah, we'll circle back around to the this follow-up question. Great.
Okay, thanks. So the final compliance option is working with a HERS rater. So this is bringing in a third party to do a comparative modeling of the overall performance of the building, taking everything into account. A HERS rating is a linear scale with a reference design of 100 as being, you know, the middle ground, the basis, and then any point below that is higher performing than the reference design. So looking at a HERS score, the lower the HERS score, the more overall efficient the building is. So the HERS maximum threshold here is what we're looking at when you're doing the HERS modeling and the HERS rating. That's the threshold to be hitting. There's unfortunately a contradiction in the language that's published and available right now for the 2024 RBES. This right here, if you see this, 60 for base code and 59 for stretch, are what I believe and what we believe to be the maximum HERS score for the 2024 RBES. But in the document itself right now, 54 and 47 is also referenced. That was what you know, early versions of the code update were calling for. But in the process of the code update cycle, it landed at 60 and 59. I did have an inquiry in with the Department of Public Service yesterday to try to get clarification on that. And this is where we're landing, but it's not verified yet. So that, as a basis to work off of for the time being, let's call it 60 for base and 59 for stretch code. For comparison, what's in the 2020 RBES right now for maximum HERS score is 61 for base and 54 for stretch code. And yes, that is meaning that for the 2024 RBES, the maximum HERS score and the efficiency related, you know, performance metric for that for stretch code is higher, meaning it's less performing than what the code is calling for right now for stretch code. So it's kind of a shift We don't have the time to get into how that came to be, but this is what we're going off of, is 60 for base and 59 for stretch code. Up to 5 points for showing compliance can go towards, it can be earned from renewables. You can't just have, you have to be showing that the building itself is aligned with compliance with the code for the performance of the building and the mechanicals itself, and not just a poor performing building that is covered in solar panels, and that being the way to drop your HERS score. So when you're doing a HERS rating and you have renewables incorporated in the project, if there's solar involved, you're going to be doing a HERS score with renewables and then a comparative HERS score without renewables. So taking both of those into account. So the process of having a rating done, if you've worked with us previously in our new construction program, then you work through the HERS rating process, and you're hiring a rater ideally at the beginning of the construction design process. And the HERS rater is an integral part of the construction team, where the rater is actually reviewing the plans and specs while still on paper and doing a preliminary rating of taking those performance specifications and the building component information, the full plan set, and putting that into the rating tool, the modeling tool, and doing a preliminary rating that would show where does this design, as it is standing right now, landing in relation to what the code is requiring for compliance. So this is a great way to guide the construction process. I mean, the RBES check tool is a similar approach, where you can, enter in your proposed components into the tool, model out how they're looking comparatively towards what the code would require, and then make any changes or adjustments before you start putting the building together on the ground to get you towards code compliance. So following this process, it gives you a clear roadmap before you even start construction as to alignment with code. And it also is a pretty handy tool to give you some comparative analysis of the impact of different parts of the building will have on the overall performance. And it also can provide some really good data to guide some of the mechanical equipment choices as well along the way. So ideally, again, there's that preliminary rating. The HERS rater is required to come in and verify the thermal envelope before the building shell is closed up with finishes. So this is part of the process. This is a third-party verification of code compliance. So when the thermal envelope inspection happens when air barrier is complete, insulation is complete in cavities, and before interior finishes come up, the rater is required to come out, take a look at that, verify everything has been done and done appropriately, verify R values, and then building can be finished. And then a final inspection is done where the rater would come back out, capture the final as-built details and square footages, et cetera, areas, et cetera, of the building if anything's changed from what the design plans had called for, perform a blower door test to verify the building envelope air leakage, and then verify the flow rates of the ventilation equipment as well too, which is another huge benefit to have, of not only knowing that you have a ventilation system installed in the building, but that it's actually working as designed and you're getting appropriate flows room by room. So that final inspection occurs, the data is collected, and then the HERS rater takes those final building data points, puts them into the energy model, into the rating tool, and completes a final HERS rating and a HERS score. And that rating certificate accompanies the completed RBES certificate as the project documentation for showing code compliance. So considerations around using this option versus res check or prescriptive compliance. I think it allows the most flexibility to show compliance with the code, because you can balance out a really good mechanical system with maybe some components of the building envelope that are not as good as you'd want them to be, but the design kind of complicates the getting to a higher performing shell in certain areas. But it's very flexible, and it also takes the onus of the code compliance piece off of the GC or builder's shoulders throughout the process, and also gives you a pretty clear guidance point, again, from the beginning before construction begins as to the big picture here, that you're on the right path and you can build what you've got designed and get you to the outcome of a code compliant home with a completed code certificate as well at the end, that you're not trying to navigate on your own as the builder. So here's some screenshots of what one of the energy modeling tools looks like, and the breakdown of building components here. So this is the REM rate tool, which is what Efficiency Vermont had used as the modeling tool for HERS ratings. And it's similar to ResCheck, but goes into a much more granular level of detail. This is an example of the inputs for windows on a building. So, this is taking into account like very specific details of orientation, which wall type, if they've got different wall types of different assembly components, and this comes into play if you have an addition or an existing components of the building as well as new. Taking into account orientation, any overhangs and shading. If you have deeper soffits that are partially shading the windows, you're actually accounting for that into the inputs here. So it really goes into, again, pretty granular detail in each of the components that you're entering. So there's data points for every building component type, every building mechanical type. This is where if you have, ductless heat pumps in the home, plus a boiler and a wood stove, all of those different mechanical equipment heating types are going to be added individually and affect the overall modeling. There's an analysis tool that actually starts to give you data and details based on all of your inputs on what the loads of the building will look like. This is not intended to take the place of a ACA Manual J design load calculation for sizing mechanical equipment for heating and cooling, but it does model out that data. So this can give you at least a good basis to then have informed conversations with your mechanical contractor what the very well detailed energy modeling of the building is providing for estimated design loads and annual loads for heating, cooling, water heating, etc. The impact of anything with renewables that you may be putting into the building as well. So it's a lot of great data that comes out of using a rating tool. This is an example of the final rating certificate of the data that is generated from the inputs of what you are modeling for the building. You're using cost data in this as well that is specific to what the market is of where you're building. So you're actually defining what the per unit costs are for electricity and fuel in the modeling data that you're putting together. This is the actual documentation of the different component types, equipment types of the building, square footage, ventilation equipment installed, the distribution type for heating and cooling, who's provided the rating, etc. So this is the final HERS score. This example here shows a negative HERS score, which is what can happen if you are putting enough photovoltaics on a building to cover the full estimated annual electrical consumption load for the building, and then plus some a little bit here too in this example. So what this is modeled is that the area of the PV system and the annual estimated kilowatt hour production of that PV system will produce a more electricity than what the house is estimated to consume annually for what was modeled. So these are a couple other examples of other reports that it can be generated from that rating tool as well. There is a tax credit, builder's tax credit available. So the modeling tool here and the HERS rater can provide that documentation for a builder to use to apply for and earn that tax credit. There's other reports that can be generated from the data on the building that get into, again, more detail about the design of what you've put together for the building. This is where you can start to, again, have more informed conversations with mechanical contractors on what the sizing for the equipment needs to be for the building. This can give you data on what you should be looking at for ventilation design as well. So it's a lot of great data that can come out from working with a HERS rater and working with this modeling approach. I'm just going to go through this last couple slides on stretch code to just nail this down, and then we can open it up for conversation here and answer any further questions at the end. So just to underscore stretch code again, stretch code is more stringent than the base code. If you are working on a project where an Act 250 permit is in play, this is often with developments, stretch code needs to be met rather than base code. Individual jurisdictions, towns can require stretch code as a more stringent compliant for local construction. South Burlington is the only municipality in the state so far that has done so. So just something to be aware of, where you're building and where stretch code is triggered or would be required. As has been noted in the chat here, compliance options for stretch code define the package option, the table, picking a package and then earning points, or having a HERS rating done. Can't use ResCheck, as we talked about here just a moment ago. And again, just to underscore the earlier slides here, this is the table and the package points that are in the 2020 RBES. This is now gone and combined in the single package, again, our single table here and single package option as well. So base and stretch code are combined under that single package option, and the enhanced points requirements here as well. Just one last section too of other components that come into play with the 2024 RBES that are different and beyond what is in the 2020 RBES. Tiny houses have been defined as their own building typology and category. So there's specifics here about different component requirements, definitions. You'll have to look in chapter 2 of the code to define, to see what defines a tiny house. But if you're building a tiny house, it has its own component and ventilation requirements different than what the code would require for a standard single family building. Needing to have 200 amp service at a minimum for any new construction as well. EV charging and EV charging equipment and spaces and availability in the panel and sockets available are required now for both single family and multifamily. The current code, it's only a requirement that comes into play if you're building multifamily. So any single family home now is required to at least have a single level 2 capable charging port available. Solar ready is another thing that comes into play. There's not a lot of detail to offer on this other than what you see here and what is in the code, but something to look at in more detail as far as what the solar ready definitions are. And that comes into play with the design and having area of the roof and or on the ground that are accessible and open for renewables for PV to be installed either at the time of construction or at a later date. So I'll leave it at that. I had another bunch of slides here to go into existing buildings, but we don't need to talk about that here today. The emphasis of today was really about getting into more detail on those 3 compliance options for new construction. So yeah, happy to answer questions and follow up from the previous questions here as well.
Thanks, Steve. If you want to skip to your last slide, just so your contact information is up.
Sure.
Great. All right. So we can go back to the follow-up question.
So I'm looking at Kate. I think you had a question here. Limits on fenestration. Wondering if this is how some of the award-winning AIA homes that have quite a bit of glass, which would seem to use a lot of energy, are able to meet code. Am I correct in believing that they are able to do this under the package prescriptive method because there is no limit on fenestration limit? Yeah, I mean, the glazing requirements are no longer, minimum, maximum glazing requirements no longer come into play. So I guess that's a yes to that question. That we'll see all different types of designs out there now that can be compliant with the code.
And next, just curious question of maybe a cost range for a HERS rater.
Sure. I mean, the frame of reference for that would be that Efficiency Vermont had been working with third-party raters for a bit as we were transitioning from our new construction program and closing out existing projects a couple of years ago. So depending on the services and what you're actually looking to get out of the rater, it really is more a conversation about what you want them to do and how far you want them to go with the project. It also is, dependent on how complicated the building is and the design is and what's involved with the work. So, it's landed between, $1,500 and $3,500, $4,000. It could be a range. So it really is, again, dependent on a lot of factors. In the grand scheme of things, whatever the cost may be for working with that HERS rater in the overall project cost, it's a pretty good deal in the end when you look at the benefit of what you get out of hiring that HERS rater, and as a line item cost in a $1 million build, it's mixed in there with the coffee and donuts budget for the crew. So something worth looking into.
Great. Do we have an idea of when ResCheck might be available for the revised code?
Can't say on that. That would be a question to refer to the Department of Public Service and what their timeline is for having that updated.
And are the NEMA 4 electrical boxes still required by the 2024 RBES? Electrical supply houses have little, if any, supply of these.
I have no idea, my friend. I don't know. I would have to dig into that in more detail. So don't have an answer on that one.
All right. Can a home with no viable solar PV SkyDome get renewables credit for their house by using remote location group metering?
I think so. I think as long as you're accounting for the future availability of renewables to be used to take up some of the load of the building, I think that is accountable in what is defined in the code. So yeah, that would be something to look into more detail in. It is in chapter 4, the solar ready requirements towards the end of chapter 4. So look into that section in a little bit more detail. And then also that would be another thing to, you could contact the department as well to see if there's an interpretation needed to allow for that as well.
Thanks. Next, has there been discussion with the state or local fire marshals regarding issues with EV chargers in multifamily garages?
That I don't know. That would be something to reach out to the Department of Fire Safety to ask them where that stands. They definitely would have an answer for you directly on that.
Yeah. And last question, are there still incentives offered to offset some of the HERS rater costs?
Yes, if you are enrolled in Efficiency Vermont's RNC residential new construction EEN trade group, then that is an offer that we still have available at this time. So a little pitch there to enroll and join our EEN trade network if you haven't already. But if you are a member of the trade group, then you can reach out to us and we can talk through and tell you how that applies and how that works.
And I think that wraps it up. I don't see any other hands or any other questions.